Hello world, welcome to this brand new part 3 tutorial about our Docker tutorial series. Today we're gonna learn a little bit about Docker images by playing with an image called BusyBox. Now that we have everything set up, it's time to get our hands dirty. In this section, we're going to run a BusyBox container on our system and get a taste of the Docker run command. To get started, let's run the following in our terminal. Let's start a terminal. Docker pull busybox. Sudo docker pull busybox. Depending on how you've installed Docker on your system, you might see a permission denied error after running the above command. If you're on Mac, make sure the Docker engine is running. If you're on Linux, then prefix your Docker command with sudo. Alternatively, you can create a Docker group to get rid of this issue. The pull command fetches the BusyBox image from the Docker registry and saves it to our system. You can use the Docker images command to see a list of all images on your system. Docker sudo docker images. Great. You see here we have just one image in this system, BusyBox. Great. Let's now run a Docker container based on this image. To do that, we're going to use the almighty docker run command. Docker run busybox. Sudo docker run busybox. Wait, nothing happened. Is that a bug? Well, no. Behind the scenes, a lot of stuff happened. When you call run, the Docker client finds the image BusyBox, in this case, loads up the container and then runs a command in that container. When we run docker run busybox, we didn't provide a command so the container booted up, ran an empty command and then exited. Well, yeah, kind of a bummer. Let's try something more exciting. Our sudo docker run busybox echo hello world. All right. Okay. Sudo docker run busybox echo hello world. Nice. Finally, we see some output. In this case, the Docker client dutifully ran the echo command in our BusyBox container and then exited it. If you have noticed, all of that happened pretty quickly. Imagine booting up a virtual machine, running a command and then killing it. Now you know what they say, containers are fast. Okay, now it's time to see the docker ps command. The docker ps command shows you all containers that are currently running. Sudo docker ps. Since no containers are running, we see a blank line. Let's try a more useful variant. Docker ps a. Sudo docker ps a. So what's the above line is a list of containers that we ran. Do notice that status column shows that the containers exited a few minutes ago, 58 seconds ago to be precise. You're probably wondering if there is a way to run more than just one command in a container. Let's try that now. Docker run sudo docker run it busybox sh. Running the run command with the it flag attaches us to an interactive TTY in the container. Now we can run as many commands in the container as we want. Take some time to run your favorite command. For example, lsa, see, check disk home, lsa. There is a danger zone though. If you're feeling particularly adventurous, and I know I am, you can try rm rf bin in the container. Then make sure you run this command in the container and not your laptop or desktop. Doing this will not make any other command like ls echo work. Once everything stops working, you can exit the container, type exit and then press enter, and then start it up again with a docker run it busybox sh command. Since Docker creates a new container every time, everything should start working again. Let's just try that. Okay. So LSA is no longer work. Okay. Echo. Wait. RF bin. Now we've removed the bin directory. ls command no longer works. As you can see, it's no longer working because the bin directory has been erased. Let's now exit the container and run it again. Sudo docker run it busybox sh. Now lsa. Wow, the bin directory has been restored. lsa. Okay. That concludes our tour of the mighty docker run command, which would most likely that concludes our tour of docker run, which would most likely be the command we'll use the most often. It makes sense to spend some time getting comfortable with it. To find out more about run, you can use docker run help to see a list of flags that it supports. Sudo docker run help. As you can see, we have a list of all the flags that it supports. As we proceed further, we'll see a few more variants of docker run. Before we move ahead though, let's quickly talk about deleting containers. We saw above that we can still see remnants of the containers even after we've exited by running docker psa. Sudo docker psa. Throughout this tutorial, you'll run docker run multiple times, and leaving stray containers will eat up this space. Hence, as a rule of thumb, I clean up containers once I'm done with them. To do that, you can run docker rm command. Just copy the container ID from the above and pass them alongside the command. Docker rm for remove. Let's try eb2a61. Okay, sudo docker rm eb2a61 d29 Okay, I have to copy this. Sudo docker remove. On deletion, you should see the ID echoed back to you. If you have a bunch of containers to delete on the go, copy pasting IDs can be tedious. In that case, you can simply run docker container prune. Warning, this will remove all stopped containers. Are you sure you want to continue? Then yes. Okay, sudo docker container prune. Yes. All right. So let's get back to the terminology used in this video, in this small tutorial. In the last section, we used a lot of Docker specific jargon, which might be confusing to some. So before we go further, let me clarify some terminology that is used frequently in the Docker ecosystem. Images, the blueprint of our application, which forms the basis of containers. In the demo above, we use docker pull command to download the BusyBox image. Containers, created from Docker images and run actual application. We create containers using Docker run, which we did using the BusyBox image that we downloaded. A list of running containers can be seen using the docker ps command. Docker daemon, the background service running on the host that manages building, running, and distributing Docker containers. The daemon is the process that runs in the operating system to which clients talk to. Docker client, the command line tool that allows the user to interact with a daemon. More generally, there can be other forms of clients too, such as Kitematic, which provide a GUI to the user. Docker Hub, a registry of Docker images. You can think of the registry as a directory of all available Docker images. If required, one can host their own Docker registries and can use them for pulling images. Thank you for following this tutorial. I'll see you in part 4 next time. Bye bye, and until then, keep coding. See you next time.